So remember that yesterday we looked at our two parent functions for our sine and cosine graph. And we ended up with our sine curve and our cosine curve, which look very similar. They've just kind of been scooted over one way or the other. Okay. Today we're going to look at what happens when we add some other numbers into our equations. So we're specifically going to look at things that are being multiplied on the outside or things that are being multiplied on the inside. Alright, so if we look at our sine graph, that's what we looked at yesterday, agreed? Yeah. Now in the past, when we've multiplied something to the front, what has that done to our graph?
A lot of things.
Not usually.
Some things.
It has impacted it. It's actually been the same letter. So like if I have a times x squared, so I multiply my x squared graph by something on the front, what does that do? It stretches or compresses it. So do we think that this might be similar? Maybe? It is. So what did we talk about yesterday were our key points? We had 4 of them. Our quadrant points. So remember we had 0, 0 for our sine graph. Then we want to look at where it ends, which we said was 1 period, which is 2 pi. And then we also looked at halfway in between is pi, and then we have a max and a min of pi over 2 and 3 pi over 2. So if I were to change my a value, say to 2, maybe, come on, there. What does it look like has happened to my graph?
It's stretched.
It's been stretched away from my x-axis, specifically by how much? By 2, right? So now, instead of my maximum being at -1 and 1, we're at -2 and 2. What about if we go to, say, 4? What do we think they're going to be at now?
4.
And?
What? -4.
There you go. Now, did anything else about my graph change? Besides that it just got bigger?
Did the space between the cross the x-axis?
I don't know, did it? Where does it normally start?
0 and 2 pi.
Uh-huh. And then halfway in between is 5. So really the only thing that changed was the stuff on the outside. Now what other option do we have that might change the distance between those things?
Decimal?
So even if it's a fraction, right?
Okay.
That's just going to compress it. So now we're going to be at whatever the decimal is instead.
Maybe if x is multiplied by something?
There we go. So notice that when I have a number on the inside, we can think of it like stretching or compressing it horizontally. Does that make sense? So when it's on the outside, it stretches or compresses it vertically. If it's on the inside, it's going to stretch or compress it horizontally, kind of like an accordion. Yeah? So if I make my b value bigger, so right now we start at 0 and we end at 2 pi. So let's say I put a 2 there so that I have 2x on the inside. What do we think is going to change?
Take the space between the one, so like 2 pi would be the halfway point, and then the end of 4 pi. Oh, that's interesting.
So what did it do? It was compressed horizontally, right? So the distance that it took to go all the way through on my values got shorter, right? What would happen if I made that number bigger?
It would become the end. Yeah. Wow.
Yes? Now what happens if I make that number a fraction? So now instead of ending at 2 pi is our halfway point. So what's that mean that we are ending at?
4 pi.
4 pi. So what's the relationship between the period, which again, remember I talked about yesterday that the period is how long it's going to take to go through all the values, and our b value? Are they directly related?
Yes.
Directly meaning I'm multiplying them together?
Yeah, right?
So like if my b value was 2, did we get 4 pi?
Oh, no, it's like...
So they're not directly. It turned into a half of it, right? So what are we doing then?
dividing.
Dividing. So they're inversely related. Yes? So we have two things. We have amplitude and we have period. So the amplitude of the graph is going to be half the distance between the maximum and the minimum. So like for our normal sine of x graph, what's our maximum? What's our minimum? -1. So what's the distance between our maximum and minimum? 2. So what's half the distance between our maximum and minimum? 1. So for normal sine of x, our amplitude would be 1. In general, if we have some other number being multiplied, your amplitude is just going to be the absolute value of a, for whatever number's on the outside. Agreed?
So it's just showing you like how far it is away from the x-axis?
Yes. So that number is going to turn into our maximum and our minimum. Alright? And then we also said, so we've talked about the period is the distance. So distance is x values. We're talking about left to right. It takes to complete a full cycle. So remember, a cycle is getting all of those values. Or basically one full rotation of our unit circle. Now, which one of those did we say the A or B affects that? The B value. Okay, so what's our normal period of our sine? 2 pi. Is it the same for cosine? Yes. They both have the same period and amplitude. Okay. Now, if we have some other number being multiplied on the inside, we said that they are what? Inversely related. So your new period would be 2 pi divided by whatever your b value is. Are you with me? Questions on that so far? So those are our first two transformations, and those are what we're going to look at today. We'll look at the last two tomorrow. Alright, so let's look at some examples. So what kind of graph do we have here? Cosine. And what's happening to our cosine?
It's being compressed.
Okay. So what's changing?
The minimum variable.
What's our new vocab word that we just learned? The amplitude. Yes. So in general, it's going to be a good idea to write out the information that we know. Because not only does that help you graph it, but also for your test, I'm not going to have you graph 4 or 5 functions. An easy way for me to test you on stuff like that is, hey, what is the period of this graph? What is the amplitude of this graph? So we need to make sure that we can find each of the pieces by themselves. Okay, so what is our amplitude for this graph? 1/2. Do I have anything being multiplied on the inside? No. So what's our b value in that case? 1, which means that our period would be 2 pi divided by 1, which is just 2 pi. So we haven't changed our x distances, just our y distances. So I'm going to go from 0 to 2 pi. So now, instead of having a max and min at 1 and -1, where are our max and min going to be? 1/2. Now, what y value does cosine start at? 0? Or something else? So remember back to yesterday, what was our pattern for cosine? Starts at 1, which is its what? Yeah, it's maximum. So it starts at a maximum and ends at a maximum. But instead of starting at 1 this time, what do we want to start it at? 1/2, because that's our maximum. So remember that even if the value changes, the pattern won't. So like it's still starting at a maximum and ending at a maximum. It's just our maximum is 1/2 this time instead of 1. So what's halfway in between? You're starting in your pi, and specifically that would be our, instead our negative, which is the what? The minimum. And in this case, what is our minimum going to be? -1/2. And then what's halfway in between your maxes and mins? Zeros. So I would have a 0 at pi over 2 and a 0 at 3 pi over 2. Agreed? So we said that one cycle is just all of those values once. So what would I do if I wanted to graph 2 cycles?
Do it again?
Do it again. Which way?
Which way do you want to go?
Does it matter?
Kind of.
Not really.
Well, which way do you want to go?
Well, since I already have the left side of my graph here, it's probably easier for me to go to the left, but you could also add it on to the right. So on some of your questions on your homework, it is going to say graph 2 full cycles. So that means that you would either need to continue on, and so where would it end on the right side for 2 full cycles?
4 pi?
4 pi instead. Or -2 pi. So either way. Are you okay with that? Yes? Okay. Alright, so now I want you to try this one on your own. Have I changed anything on my x-axis? No, so I'm still starting and stopping where and where?
2 pi. No,
0 and 2 pi. So the period of this graph is still 2 pi. but this time was the amplitude of the graph. 3. So what's happened to our graph? It's been stretched away from it. So where is our graph going to start on our y-axis? Which also means it has to end at what? 3. Halfway in between, we would be at -3. And then halfway in between each of those, we have our zeros. So it looks like that. Yes? I'm not going to grade how pretty your curve is, so don't worry about that. Just don't make them look like absolute values, though, okay? Because they're not pointed. They do need to be curved. Alright, so the other thing we need to look at is our period shifts. So let's be careful here. What is our amplitude in this case?
1.
Still 1, so that hasn't changed. That's nice. Now, in order to find the period of the graph, what was our formula? By b. And b was which number? Like, where was it located in our equation? It was before the x, right? So what was the operation in between b and x? Multiplication. So what operation do I have right now? Division. So how would I write that as multiplication?
You say it's like the same, that's just multiplied by what?
Agreed. So what's our b value here? 1/2. Do y'all see that? So just be careful, because a lot of people just want to be like, b is 2. Not really, because we're dividing by it, and remember our b value we got from whatever was being multiplied to x. So if b is 1/2, we would have 2 pi divided by 1/2, which gives us what? 4 pi? Yes? Okay.
Yeah.
So are we still starting at 0?
Oh, yeah.
Yes. But this time, where are we going to end? 4 pi. Are we all okay with that? So do I want to label by like pi's over 2s like I've been doing? Because I would have to have a pretty big graph, right? Can I change my unit? Yeah, like pi would probably be a good one. 2 pi's would probably be so 2 pi's would probably be too small to get the whole graph in there, right? But like going by pi's would be okay. We have pi, 2 pi, 3 pi, 4 pi, and then I'm still gonna go by halves on my y-axis. So what does that mean? It's gonna be really important that you do on your homework or your graphs. You have to show me your units. Otherwise, if you just show me the prettiest graph in the entire world, but you don't label anything, I have no idea if your period is correct or not. Therefore, I'm just going to count it wrong. You have to label your units in order for me to know if it's right or wrong. Now, that can either be on your graph, like I did, or you could say, the x-axis is by pi units. Does that make sense? Either way, if you don't want to put it on the graph, then you at least have to have it out to the side. So that way I know what your unit is. Yes?
What's on the x-axis? That's pi.
This one? That's 4 pi. Is that better? Okay. So this time we have a sine graph. So what does sine start at? A 0. Okay, so what does that mean it's going to end at? A 0. Okay, and then what's halfway in between? A 0. And where would that be located this time? At 2 pi. And then halfway in between would be a maximum, which would be at 1 because our amplitude hasn't changed. And then halfway in between my second two zeros is our minimum. So where is my maximum located? What x value? Pi. Where is my minimum located? 3 pi. Now those values were easy, right? I just took them and divided by 2. What happens if our period was, say, 5 pi? So what's the pattern for sine? We start at what? A 0. And then next we have our maximum. Then we have another 0. Then we have our minimum, and then we end on a 0. So if my period was 5 pi, would I still start at an x value of 0? So what would I end at? 5 pi. I would end at a 0, but my x value would be 5 pi, right? Because that's what the period or how long it's going to take. Yes? So where would my second 0 be?
So it would be 5 over 2 pi.
Correct. How would we write that?
That's like 2.5 pi.
No. 5 pi
Over 2.
over 2. Are we all okay with that?
Yeah.
So then how would I figure out where my maximum is at?
Divide that in.
Correct, which would be at,
Yeah.
so dividing by 2 is the same thing as multiplying by a half. So 5 pi over 2 times 1/2 would give us 5 pi over 4. Okay, those ones are all relatively easy. What about my minimum? So it's still halfway in between, right? So if it was negative 5 pi over 4, that would be going to the left.
So I think you would just add like where the maximum is onto where the halfway point is.
Okay, yeah, you could do it that way. So like if my 0 is at 5 pi over 2, basically what he's saying is that halfway in between, or half of that would be 5 pi over 4. So if we took 5 pi over 4 and added to 5 pi over 2, it would get us halfway in between those two.
You could multiply 5 pi by 3/4.
The other way we could do it is, how do I find like a middle of anything? Yes, but like a midpoint. So like if I have two values and I want to find the middle or the average of those two things, what would you do? Add them and divide by the amount. In this case, we have 2 of them, right? So we would do 5 pi over 2 plus 5 pi. So we end up with 5 pi. If we need to get that with a denominator of 2, that would be 10 pi over 2. So we end up with 15 pi over 2. And then we would have to divide by 2. So we end up with 15 pi over 4. So yes, if we multiplied 5 pi by 3/4, right, we would get 15 pi over 4. And also if you added 5 pi over 2 to 5 pi over 4, you should also get 15 pi over 4. The only hard part about that is going to be tomorrow. We won't be starting at 0. So those two ways wouldn't work if we don't start at 0. Does that make sense? Whereas adding them and dividing by 2 will always work, because that will always find me the midpoint of those two values. Does that make sense? Are y'all with me? Like I said, on some of our stuff, we won't always have super pretty numbers that we can just half, like 4 pi. Some of them will be like this one, and we just can write it out pretty easily. But I want you to make sure that you know how to find halves of things that don't turn out super pretty. But we do want to leave them as fractions, so don't put like 0.75 pi. That doesn't make a whole lot of sense, okay? Are we with me? So leave it in fraction form if you can. Questions, concerns, comments on any of that stuff? No? Alright. then we shall work on our homework.